Welcome, Michael here at Wickerson Studios. I'm going to continue with what I was working on, the second half of dealing with Euclid's elements. Book 1, Proposition 2. So you're going to want to start. You're going to say exactly what you want to do off the bat. We'll just open this up, extend it, type in our comments. Book 1, Proposition 2, and to place a straight line equal to a given straight line at a given point as an extremity. That's the exercise. It seems strange that this is this complex for just the second proposition, the building of this, but it's interesting to see that you can do it just from the basic definitions that come out. So let's just grab that to start, make it so you can see it, and let's begin with how I model anything. Top view, no problem. I did open Grasshopper, I did open G2 to get started, and I've done that in my last video because I will be using both, and I'll just plug through this, say as little as possible. Well, I'll say as little as possible. I like this because then I can start incorporating ranges and trigonometry in this section and start to move these geometries in lists and trees. I like a number slider and radius that's changeable. And if you have to zoom extends all to make everything big, you can do that, but I like it a little smaller so you can see what's going on, especially the extend curves. I will want to evaluate this circle through curves analysis at 2 points. Whenever I'm evaluating a circle, a curve, and a curve, I'm going to want to do that by using my inputs constant picker. I like to shrink that because I use it quite a bit. I'm going to want to use a little math. I don't want to multiply that a couple times for each one. The first one I want to hard code in at 0.5, and the second one I'm going to want to have a number slider, and that number slider doesn't have to be the -1, but sometimes it's nice to have a number slider that goes from 0, -1 to 1. I like to use that a lot, not -1000, -1. And I will evaluate that curve at this point, and I'm going to pull that one down to right about there. So I've got point here, point here, point here, point here. And then I'm going to want a point that I can actually evaluate to. And I'm going to use the sliders that go from -1 to 1. I'm going to put that point down around here in this bottom quadrant. And that should get us started with some points, and now we need some data from these points. So the first thing we do after that, we want to come in and we want to be able to create some lines. And the first lines I'm going to create, I'm not going to deal in vectors, are going to be from this point to this point. So you can see I have a curve here. I'm also going to want to go from that point to the next evaluated point, that point. And from those two, this line itself, I'm going to use a tool called extend curve. And it's sloppy coding a little bit, but it allows you to take that and move it out in each direction so you can then evaluate that toy. I'm going to go back to analysis. I'm going to evaluate that longer curve from 0 to 1, which means I can just use a number slider from 0 to 1. And that will put a point along that curve at some point. So you can think of this as point D, this is point G, this is point B. I'm trying to produce point A, and I'm trying to get everything in cahoots with one another. So I'm going to produce 3 more lines. 1, 2, 3. And it's good to organize things in rows. You can't really use blocks in this, but I'm going to evaluate that point to 3 different areas. This point, and this point. And this one I actually am going to evaluate from the start point over to, I want to go from that point to the point we made here. Sorry to do it out of order. I also want to separate these points from the initial point. So I get this section, and I also want that initial section from 0. So what I've made is 3 lines. This one, and this one. And they're all good to deal with, and you'll see that this has started to form what looks like a kind of equilateral or isosceles triangle. Now it doesn't look like it when I start playing with that, so I need to gather some data from these lines. The best way to gather data from the lines is go to list length. You may want to play with that. And then another way to get lengths all around an object are at this point itself will be very interesting to gather the circle data. I'm just going to pull this one down. And I want that radius, which you can cheat now. And I think it's a little lazy to do this, to pull a line into radius, which you can pull a line into radius, but it's better to pull the length of the radius so you can see what's actually happening. And I'm actually going to try that extend curves again. This is just the way I think, and of course I'm looking at a model done, so I've extended that curve because I want to see where this crosses. I want to actually play off of intersections. And the best tool over here on intersections in Grasshopper 1 is this one. So you can literally go in and grab, let's just move this one forward, move this length up here, and let's just grab from these circles, when do these circles interface with those circles. Now, it may be all right. I have to look at my numbers. There we go. I've got it set up pretty good by inner circle, and just playing around, taking a look, changing my sizes, looking at how my geometries are starting to play. I want this one to kind of hit here, so I'm going to see if I can hard code that, but without confusing it. I've got a list length here, I've got crossing points. I'm going to want to find another line from these points. I'll pull that up so it's not bouncing to these points. There's a nice line that's been formed. This point should not be 2 points. So something's wrong with my model and my data. So I'm going to come back and see where I've got it going wrong. This one's only coming back to -2. If I pull it back to here, you'll see the model starts to look right. So that's interesting that I've done that. Let me check my numbers. What about a -3? That's all right. This point probably could be a -0.4, -0.6. Just kind of playing off of this, getting my model. 0.05. This is way too high. I want to pull that point above the other one. There we go. Now it's starting to look a little better. I needed a very small number here because I didn't want this point on this side of this long extended curve. I wanted this point pulled back over here, and that will start to make the model work a little better. And it takes the 2 points and makes that 1 point. So if you didn't notice that, as I come, that will become 2 points at some point, a list of items. And over here, I just want the one intersection over here. And this allows this to be our original line. If you take a look from B to whatever we want to call it, B to C, and we'll call this G, so we can split up G, this one in between these curves and these curves. They're hard to see once you put data after them. And then this, considering it being A, and this is where it crosses. So we're trying to find from this point that we've made, and I hope this doesn't get too confusing, as I move this point, let's say A, I want to find a length here that's similar to length to our original line. So the length of this line's got to become this line. So we're going to keep plugging through our script until we make that work. And let's take a look back at where we were. We've got that line on here. From this data, we can always grab another circle. And from that circle, that's not what we want to do. We want to put another circle on, but we want this length to be that circle. So there you go. Now you can start seeing that that's the intersection we want to actually make. So I'm going to grab another intersect tool, and I'm going to intersect this circle with this circle, and that will give us this point. Now what's happened now is we've made an isosceles triangle. If we play this right, we'll see that that can actually become an equilateral triangle. But always, if you look at it, this line is always the length of this line. which means minusing these two sections, which comes in handy in further scripts. This line remains length of this line, which is the length of this line, because this circle proves that. So now we have a model that if we could just get this line from here to here, we know it's the length from the original. I hope that makes sense. And what I'm going to do is I'm going to come down and I'm going to grab that line, and I'm going to know how long that is, but I'm actually going to produce another line. And sometimes when I'm working from scratch, I go here. We will take that point, and we'll come back to the other intersection point. And there we go. We have this line, and what we want to prove is that those two lines are equal. And this is where, without screwing up, because I like to file save things. Now, file saving things is one thing. I'm going to save this as proposition C. I'm going to replace it. Now, one thing you can do is you can go into datas, you can go into metas, you can go down into display widths, and I'm going to set this to a width of 12 points. And I'm going to do that twice. I'm going to take this line and put it into this one, and I'm going to put this line into this one, and this is going to be our original line blue, and this is going to be our other line orange. And now we can see no matter where we slide through that those look basically the same, but the other thing to do is actually use containers, where we can grab this container here. We can grab the other container. Let's go back to, where was my original line? My original blue line, this one, which would be fine as well. I could take that curve and just pull that one up. This line. I can find the lengths of these two in the curves, and this is just evidence of the proof. It's not proof of the proof. These are really models to testify to proofs, but you'd still have to geometrically solve things. And grabbing a param, slide it in here, put in the first one, hold down shift, works the same. And there you go. You've got two that no matter what I do, those two lines, it's a nice little model. That I can play around with. I can change wherever that point A is arbitrarily, because that's what the proof is asking, given any point or extremity. I can move that up here, but as it falls outside of the circle, it kind of defaults. That's why the model doesn't work forever, but then again, like building anything, there's certain parameters to what you can do. And then you have this really nice ability to move this around. Now, what's sad is that I actually like a couple more curves. I like this curve. This is a good one. This curve here, which I didn't generate yet. I'm going to generate it for my final points. Let's see if I did it. It's pretty well organized here. Let me grab these guys, bring them over here. This curve, I would like to go from this point curve. I like this diagram because it makes sense. I actually might plug that one into here, and then go from the original point as well. And because that's the original point, I think I can just grab a relay. I can relay that into here. And then this point can become something of interest here. And I can pull that line into here, holding the same value, and I can change the color of that to red. And there we go. And then the other point that I like to have as a sample, and I'm going to put it back on in my other model, so just give me a second. Orange, green is what I had the blue set for, so it shouldn't do that. Red is in the middle, so I've swapped my red and my green for my samples. Just give me a second. And the other one, I think that's it. If I think about, that's the same one. That's a nice little model. The only thing you might want to extend is this is kind of these two original lines, which are nice. This whole line is pretty nice, but you can see that red, because you get a bit more of a compass or a protractor, so you can take that one, and let's just take that one to grab one more meta and pull it back, and we'll just take this line and we'll put it in, and we'll make that green. Yeah, so that whole line's green, and that's a little more interesting than looking at the other one. And then the other line that I might want to do as green, the same thing, is I want to find my original one before I split it. Not this one. From point in the center to this one might be a nice one to bring in. And so that would, oops, that one. Hopefully I don't bug out. Metas actually bug out. So there you go. Now you have a nice model. And I think what I'll do instead of that orange one, which was half, which was testing, we can take this one to orange. And now you have a really nice model that we can continue with the visuals of having a little bit of control of making a model. Now this is going to drive some other geometries, which is pretty fun. As we get through this and rotate this one through, as we move this point, obviously in this range or back and forth here, we can open and close that little tool. And this is how we're going to drive the second section of it. So hopefully you can follow through that. You see how I'm kind of going, using a proof to build a model. And now we try and amp it up and do something spectacular with it. So I'll give you another 10 minutes on my third part. We'll see how it goes. Thanks for watching.